Hi, this is a short video that's going to explain to you how we do our mobile eye tracking scoring. When the eye tracking is mobile, obviously the scene is changing constantly, and we needed a method to designate areas or elements that appear in the scene but are not always there. A way of scoring the fixations on those elements. So we've developed a sort of semi-autonomous way of doing that, and I'll just go through that and so that you can see how it works. Over on the left side, we kind of have designated a file that we're going to put our scoring information into, and we also have a list of the broken out images from a video. In this case, this was a video generated by a simulation, so the images are pretty good, but it doesn't look like an actual scene, but it is exactly the same paradigm. On the right-hand side, we created what we call a scoring element file. And in that file, we just created examples of several objects that we would be interested in scoring in this video. So we have a roadway scene. So when the fixations are on the roadway, we're gonna score as a roadway. Traffic signal, buildings, vehicles, and different road signs. So why don't we just go ahead and show you how this process would work. So we're starting with a fixation, and you can see the fixation is on one of the highway signs. So we just click on highway sign, highway direction sign, and we've scored that fixation. We can immediately go to the next fixation. In this case, it's just the roadway, so we click on roadway and go to the next fixation. Here, we don't have any particular item that fixation is on, so we just go to the next fixation. What you'll notice is happening as I go to the next fixation is that I'm automatically skipping all of the intervening frames between fixations, so there'd never be confusion. If you were looking at raw point of regard, you wouldn't really know if someone fixated or if that was sort of an intermediate point at which point of regard was computed, but there really wasn't a fixation on the target. So not only do we get more accurate information about what the subject looked at in truth, but we also get an idea of how long, because that fixation is of a certain length, which is indicated by the size of the circle. You'll also note that as we go through, this is a highway sign, another highway sign, and another highway sign. I'll be a little generous with that one. Here I'll call that roadway. You'll also notice that we have a nice large indicator so that it's easy for a scorer to find the fixation in the image as it comes up. Let me go back. I didn't get that. Call that a roadway. Call that a roadway. And this is really nothing of interest. We'll call that a roadway. Obviously, the subject was just staring at the road in this case. I'll call that a roadway. So these are. Let me just skip on because he does turn into a city. Looking at a billboard, which we'll score. We can score these as roadways. There's a building. So you can see this process is very, very quick and very simple to do. And at the end of the process, we just save our fixation scoring file that now contains the information that we've put in, indicating what they were looking at. So it's a very simple process. And then if someone wants to take a break, they can save the file, and it will automatically come back, and they can resume scoring. If it's a particularly long file, it can all be done. It could be done in more than one session. So it's a very reasonable way of sort of scoring for what is really a very complex process, or can be a complex process, depending on the scene being viewed by the subject. Thank you.